Have you ever felt like your computer just has a mind of its own? Well, you're not entirely wrong. Today, we're going to pull back the curtain and reveal the hidden power, the secret boss that's running the entire show inside your machine.
Oh, yeah, we have all been there. You're just staring at a frozen screen, that spinning wheel of doom, just begging it to cooperate. You know, that moment of pure frustration is exactly why we're here. Understanding what's really happening under the hood, that's the first step to taking back control.
So if you're not 100% in charge, then who is? Who's juggling all the tasks, making all the split-second decisions, and, keeping things from crashing, well, most of the time? The answer is this incredibly powerful piece of software you use every single day, probably without a second thought.
And that secret boss is, of course, the operating system. It is the powerful and often totally invisible manager that organizes literally everything from the second you hit the power button to the moment you shut it down.
Okay, so think of it like this. The OS is the essential bridge between you and all the physical parts of your computer. It's the master coordinator that makes sure your hardware, like your processor and memory, can actually run your software, like your web browser or your video games. Without it, you just have a very expensive box of parts.
And you already know these guys. Whether you're on a PC running Windows, a MacBook with macOS, or even just scrolling on your phone with Android or iOS, you are constantly interacting with an operating system. They are the absolute foundation of all modern computing.
Now, to really get a handle on what the OS does, we need a good metaphor. I mean, thinking of it as a manager is fine, but thinking of it as an air traffic controller for a ridiculously busy airport, oh, that is so much better.
Just imagine it. Every single app you open, every file you save, every key you press, that's a plane trying to take off, or land, or just taxiing to a gate. Your OS is up in the control tower, directing all of that traffic, preventing collisions, and making sure everything gets exactly where it needs to go, as efficiently as possible.
So let's break that down. When we look at the core jobs of the OS, you'll see just how complex this airport really is and how masterfully the OS keeps it all running.
What's so wild is how multitasking feels so seamless, right? For a long time, most computers only had one runway. That's a single CPU core. But it felt like dozens of planes were landing at once. The OS pulls off this incredible magic trick with lightning-fast time slicing. A program is either running, which means it's the plane currently on the runway, or it's waiting at the gate for something to happen, like a file to finish saving, or it's runnable. It's all fueled up and in the queue, just waiting for the tower to give it the green light. The OS swaps between these states thousands of times a second. And now with modern multi-core processors, it's like our airport has multiple runways, letting planes take off and land at the exact same time. It's amazing.
And memory management is just as brilliant. Your OS gives every application its own private terminal gate. That's memory isolation. This is what prevents a crash in your web browser from taking down your entire system. But what happens when the airport is totally full? Well, the OS uses virtual memory. It directs the lower priority planes to a temporary parking lot on your hard drive, freeing up that precious RAM, your active gates, for what you need right now.
And what about all the different equipment at this airport? Your mouse, your keyboard, your printer. They're all like service vehicles from totally different companies. Device drivers are like the specialized ground crew that act as translators, allowing the control tower, your OS, to give clear instructions to every single piece of hardware, no matter what language it speaks.
Okay, so how do we, the pilots, tell the control tower what we want to do? Well, we basically have two main radio channels to choose from.
The GUI, or graphical user interface, is like pointing to where you want to go on a map. It's visual, it's friendly, anyone can use it with a mouse. But the pros, they often use the CLI, the command line interface. That's like giving the tower a set of precise GPS coordinates. It's text only, sure, but it is way faster, way more powerful, and absolutely perfect for automating complex flight plans with just a few keystrokes.
All right, so the theory is great, but how does knowing all this stuff actually help us when things go wrong? Let's dive into a few real-world emergencies and see how understanding the control tower can turn total chaos into clarity.
So, take this gamer. Their PC keeps crashing right in the middle of a game. So using their system monitor, which is kind of like their view into the control tower, they find two problems. First, the ground crew for their graphics card is using an old manual. That's an outdated driver. Second, a background update is acting like this huge cargo plane trying to take off during rush hour, causing massive stutters. The fix?
update the driver, and then tell the OS to lower the priority of that update, basically telling that cargo plane to fly at night when the airport's quiet. Boom, problem solved.
Or how about this startup in Berlin? Pushing out their new code was this manual point-and-click job in the GUI, which was slow and honestly, people made mistakes. By switching to the CLI, they wrote a script, which is basically like creating a pre-filed, fully automated flight plan. Now, instead of clicking through every step, they just run one command, and the OS executes the whole complex sequence perfectly every single time. That made them faster, more reliable, and it gave them a huge competitive edge.
And finally, check out this 3D printing lab. All their computers were freezing up. A quick peek at their system monitor, like the task manager, revealed a ghost flight. It was a runaway process that was just circling the airport endlessly, hogging all the tower's attention and maxing out the CPU. Total traffic jam. But the fix was simple once they knew what to look for. They used the tool to call the tower, ground that one rogue process, and suddenly the entire airport was running smoothly again.
See, the key here is to be proactive. You got to keep an eye on your own flight traffic with Task Manager to spot those ghost flights. Keep your ground crew and your tower staff trained with the latest driver and OS updates. Make sure your airport has enough space by checking your disk, and always have a backup flight plan with system restore points. These simple checks can prevent most of those frustrating airport-wide shutdowns.
But look, this isn't just about fixing annoying problems. Understanding your computer's secret boss has some pretty profound implications for your skills and maybe even your career. Seriously, from IT support and cybersecurity, where you are literally the system's guardian, to game development and video editing, where you have to squeeze every last drop of performance out of the hardware, a deep understanding of the OS is a massive advantage. It's a foundational skill for pretty much any tech field out there.
And that, right there, is the main takeaway. When you really get how the operating system works, you are no longer just a passenger on your own computer. You're in the co-pilot seat. You can diagnose problems, you can optimize performance, and you can make your technology truly work for you.
So, now you've met the boss. You know how the airport is run. The only question left is, with this new power, this new understanding, what are you going to command your machine to do? Thanks for watching.